Hello, welcome back to Cracking the Cryptic, and well, an entertaining looking puzzle today. Just some green lines in the grid, and these are not entirely normal German whisper lines. I will warn you about that now. I'm going to have a look at that in a moment. First of all, I do want to say there's still time to have a go at Hollywood Lunchbox, our Patreon reward full of sandwich Sudokus for your delectation. Do give it a try. There is loads of work to do on those puzzles, and so many people have done them. We are very pleased with the response. Thank you very much, anybody who's had a go. And there's help available on the Discord server, on the Patreon chat channel if you need it, so check it out. Now, where else can we direct you? We can direct you to our merchandise, some great products there. We can talk also about Sven's Sudoku pad, available on the links under the video, and our apps. Now, not only do they feature Approachable Sudoku, our latest app, but also, and that is full of approachable puzzles. If you're wondering where to start out in variant Sudoku, that is the very place. If you're wondering why are these line puzzles so good and where can I do more of them, then we have an app called Line Sudoku, and that is great value too. So please check them out. They are good fun. And the source of a lot of great puzzles by great constructors. Talking of which, we are featuring a collaboration today between Lithium Ion and Holzen Atom, who have both featured on the channel before. I think more often Lithium Ion, but they have prepared a variant of German whispers for us. So I'm really looking forward to giving this a go. Do check it out on the first link under the video. You can play the puzzle yourself, and lots of people have been beating my times lately due to things that I've thought were right and weren't, and that sort of thing. But due to them being better than me. That's one of the ways you can beat my time. But I'm going to have a go at this. So I'm going to describe the rules. Normal Sudoku rules apply. That means we're going to put 1 to 9 in every row, every column, and every 3x3 box. Adjacent digits along a green German whisper line must differ by at least 5. So there has to be a difference of 5 or more between those two cells, for instance. Now, here it comes. Both digits, which can be equal, on the endpoints of a green line form a look and say clue. If, for example, the digits on both endpoints of a line, like those two cells, are 4 and 3, then the digit 3 has to appear exactly 4 times on this line, and the digit 4 has to appear exactly 3 times on the line. And there's a final clarification that the line that begins there ends there. Obviously, there would be no point in, like, if those lines weren't in that order, then we'd have straight lines instead joining them. But it's a useful idea to clarify a crossing line. So this is a 5-cell line, and this is a much longer one. Do give it a try. I've no idea what we're going to find as we try and untangle these lines. But I'm really looking forward to giving it a go. So let's get cracking. Now, I mean, I'm astonished in a way that this puzzle just survives on 5 lines and no rules. But I can see that if you had certain numbers in these line endpoints, there would be a lot of constraints. Let's start with the shortest of lines. This line only goes through 2. Oh, this line is absolutely the place to start. I can say that with some confidence. And this is because the 2 endpoint cells are in the same row, so they have to be different. I think that in this puzzle, if the 2 endpoints are the same, that is much less constraining than if they're different, because there's only one requirement of the line. If you have 2 2s on each end of a line, well, in fact, that would say these are the only 2 2s on this line, and nothing else about the line apart from its German wisperness would matter. This line, on the other hand, has only got 2 cells. It only passes through 2 boxes. The maximum number of digits of any type that you could put on this one line is 2, because there'd be 1 in box 2 and 1 in box 3. And therefore, the highest digit we can put on the endpoint of a line, yes, either way round, I'm just checking that in my head, is 2. So I think that has to be a 1-2 pair. And this means that there is 1 2 on this line, and it's in one of these 2 cells. And there are 2 1s. One of the 1s is in box 3, but the other one is in box 2. So that is the 1. And there we go, we've had a start. And that one of these is a 1. And now we can use some of the German whisper qualities. So the 3 things I love to tell you about German whisper lines are they don't have 5 on, because there's no possible neighbours. They alternate between higher than 5 and lower than 5 digits, and I'm going to use that in placing the 1 on this line that needs to go on it. And finally, 6 and 4 are difficult to place sometimes because their neighbours mustn't be able to see each other. 6 only has 1 possible neighbour, which is 1 on either side, and 4 the same. Now, this cell could contain a 6 because its neighbours don't see each other. They're not in the same row, column or box. So we've started with a line there. Now let's take the next shortest. Now, interestingly, I don't think we know what digit is on the end of this line, but we know it's not. I was going to say, do we know it's the same digit on both ends? Because I did just call it a digit there, because that's what I was thinking. But actually, again, you could have a 2 and a 1 on this. The most number of digits that could possibly appear on this line is, I suppose, 4. The point about that is, and I'm sure 4 is not the answer, but the point about that is both ends have to be low digits. I should probably be marking lows and highs in this puzzle. Therefore, these 2 are alternatingly high, that one is low. Now, the most numbers of blue digits on the line are 3. But don't think you can't have 3 in one of these cells. You can, but only if you have 3 in the other one. And that would mean 3 3s were on the line, and all of these would be 3s. These could equally both be 2s. And actually, I think this one could be a 1. And this one, not a 3 in that case, but a 2. So I think there are various possibilities, which has surprised me. But I do think that the ends of the line are from 1, 2, and 3. This one, I suppose it could be a 4. Or no, it couldn't. No, it couldn't. Yes, it could. Yes, I'm sorry. Yes, it could. If they were both 2s, that could be a 4. It's such a strange puzzle. Right. Now, I'm next just going to mark alternation. I'm choosing this line because it looks a little bit shorter to me. Actually, I think it's the same length as the line. Oh. Well, I was going to say this is very interesting because both ends are different colours. They're not. I've made a mistake, and I could tell that because this line goes through 4 boxes. The maximum number of any digit that repeats on the line is 4 times. Now that's got to mean that both ends are low. So my initial assessment that we were alternating to have different colours on both ends of the line must have been wrong. And I think it was wrong in box 6. So in fact, these are the colours on the line, and it's fine. They do alternate enough to bring us low ends at both ends. Now, I mean, I must be able to do the same with this line, which also only goes through 4 boxes. So I'm sure I can make the ends of it blue. Let's just do this. This is a straightforward way of approaching the colouring in this puzzle, and it does at least show that the line is an odd length. But I'm going to have to think about what these values in these blues are. Now, this line, I'm just being a little bit more circumspect because it goes through 1, 2, 3, 4, 5, 6, 7 boxes. Indeed, in those positions, I could put 7 in every cell. Actually, yes, they even alternate. So I can't rule out a pair of 7s in these. I think I can rule out a 7 and a 1. Which would say there was 1 7 and 7 ones. No, maybe I couldn't even rule that out. So I don't know. That line is a bit more of a mystery. I mean, they're all a bit mysterious. Oh, this digit is 3 or 4 by Sudoku. So is that one, because they both see a 1-2 pair. The only digits that can border 3 and 4 on the German whisper rules are 7, 8, and 9. Oh, we know where 5 goes in the top row. You've known that since the absolute beginning when I mentioned the rule about 5s, or because you knew it anyway. I've only just spotted from the fact that we had 4 blues and 4 oranges going on there. Now, I'm wondering about marking up cells that follow this monogamy rule about 4s and 6s not going in places where their neighbours can't see each other. So that's 1 can see each other. 1, 2 and 3 in both those places for exactly that reason. These two are both from 7, 8, 9, and that's a triple in the column. So these are from 3, 4, 5, 6, because they see 7, 8, 9 in the column, 1, 2 in the box. Oh, I'll tell you what I am going to do with this line. I think I saw before that I'm going to colour it random colours, not blue and orange, because I don't know what's high and what's low. But if we do that, we do see that the two ends, and that's what I was interested in, they are the same. It would be unbelievably helpful if we could find out that one of those ends couldn't be low. And indeed, at this end, it can't be 1 or 2. So that would be at least 3 or 4. 7 is the maximum because it's the number of boxes they go through. So that digit is 3, 4, 6, or 7. Oh, this digit can't be 6. There's only one place for 6 in the top row. There it is. Didn't see that before. Now there's only one place for 6 in the final column, and that's here. So I get to colour that cell. Now, one of these is orange. Whatever yellow or red are, they're 1 blue and 1 orange. So one of these is blue and the other one is 5. No, here's the thing. No, I was going to say we have to place 1 and 2 in this box. I'd forgotten that one of them can go in yellow or red, so don't worry about that thought. This is now a 3, 4, 5 triple, so this is 5. It's not 5, it's high. Interesting, from 7, 8 or 9. That is 2 blue. Yes, okay, I'm going to work out the colour of this cell. That is 2 blue and 2 orange. That is one of each, although we don't know which one translates to yellow and which one to red. But that means this is 3 of each colour, and this pair is therefore 1 of each colour. And therefore they include blue and 1 orange, and this is orange on the count of column 1. I mean, it's not a huge advance, but it's nonetheless got some truth to it. Now, these digits are from 2, 3, and 4. One of them is next to 9 in the row, so that's not a 9. Now one of these is a 9. One of them is next to 9. This one can't be 7, because it comes between at least 2 and 3 can't border 7. This one is 7, 8, or 9 as well. How do we keep going? I'm so intrigued that this line is not revealing its secrets. These could be a 1 and a 2, a pair of 2s, or a pair of 3s. I mean, that's quite a lot of options. This digit is 1, 2, or 3 as well. In fact, there's a 1, 2, 3 triple in the central row. I was wondering if that made this high, but I think it could still be 4 with 9s on both sides. This one could be a 4. That one could be a 4. Either of these could be a 4. No, this one can't be a 4 because its two neighbours do see each other. So one of these two is a 4. Is that useful? No, it just means one of those two is a 9. Oh, hang on. One of them is a 4. It's not this one. Because where would you... Oh no, I was thinking it would have to be 4 4s you'd put on the line. No, that's not necessarily true. But, right, I'm going back to saying this is not a 4. And my reasoning is because it would require 4 of this digit to appear on the line. Now, it couldn't be 4 4s because there are only 4 boxes the line goes through. And in box 4, it couldn't have a 4. Now, you're saying, but it could be 4 1s, or 4 2s or 4 3s. But in box 2, if you wrote a 4 in here, it couldn't have that 1, 2 or 3. So this is not a 4. And now, this means very excitingly that this is a 4, and that is going to have a significant impact on its line. Its line, wow. First of all, let's do the Sudoku. That's sitting next to 9. That puts 8 there, 7 here. There's some unwinding of digits to do as a result of that, and I'm going to do it because I do believe in Sudoku first and foremost. Now, this is saying that there are 4 of this digit on the line. Now, that could be another 4, and then those two would both be 4. They would have to be surrounded by 9s. It looks like that would work. Now, could this be a lower digit? No, it couldn't. Because if that was a 1, you would need to put 4 4s on the line, and it only passes through 4 boxes, and one of those boxes can't have a lower digit on the line. It can only have a 4 as a low digit. So this is another 4. We get loads, we put in all the 4s on the line. We get loads of 9s we can put in as a result, and then we can finish off some other high digits. And look at that, we've got a line with 4 4s on, declared at both ends. Now, I have a feeling that this is going to be important with this. So this is, well, if they're the same, this is less of a message. But if they were different, this could require 2 4s to be on the line, there and there. Okay, I don't know, we'll come back to that. I thought that was going to be the next helpful place. It probably isn't. Let's look at a 3-5 pair there, ruling 3s out of those cells. Oh, we need to place a 9 in row 2, Sudoku. In one of those cells. We need to place a 4 in row 3, which can't be there because that can't be a 9. And that's to do with its end-of-lineness. There's also a 1 in row 3. Now that can be in the red cell. Maybe I have to think about the ends of this left-hand line. Or is this one, nothing has happened to that one? I don't think anything's happened to that one. Oh, it's a very unusual puzzle. It's very interesting, actually, I have to say. This is one of the most unusual rule sets in terms of how it plays out that I've seen in a while. Now, that can't be a 6 by Sudoku. That one by the rule about neighbours in this sort of puzzle, in German whisper puzzles. This one can't be an 8, but I'm not ruling 6 out yet. Oh, yes, I am ruling 6 out, because if that was a 6, this would be a 1. Oh, no, I'm not ruling 6 out. 1, 6, 1, and a 2 there would be all right. Takes some thinking through. Now, this digit, I mean, I still don't know if it's high or low. That's ridiculous. At this stage of the puzzle, not to know whether this longest line of all starts with low digits or high digits is very surprising. But maybe I'm being too circumspect about it. Maybe it obviously starts with lows, but I'm just not sure if that's right. Oh, there's a 1, 2, 3 triple. Bingo in row 5. Oh, wow. Okay, that is absolute bingo, because that means that this digit sees a 1, 2, 3 triple and 4. And that means it's high. And that means yellow is high. And that means the ends of the line are high. And that means there is going to be 6 or 7 repeats of some digit. And since this is high, well, it can't be a different digit, or there'd be 6 7s and 7 6s, and there just aren't that many high cells on the line. Oh, sorry, I can make red low. Right, so these are the same, and they're either saying there are 6 6s on this line, which sounds absurd to me, or 7 7s, which actually sounds almost equally absurd, because the line only goes through 7 boxes. But let's start with the absurdity of 6 6s, which would mean we would have to have 1s every... Right, this box can't have a 6 in. So, whether it's 7 7s or 6 6s, all of these digits that I'm going to flash yellow have to be the same digit now, and that one actually. Because in those 5 boxes, we've got to use the same digit. Then one of these can be the same digit. And that either is the same digit if they're all 7s, or it doesn't have to be if they're 6s. Oh, this is bizarre. I don't think they can be 6s now, because, well, this one can never be a 6. And it's in our yellow flash section. It can never be a 6, because those both have to be 1. So it's 7s. There are 7 7s on this line. It's a good thing I was circumspect, because this is craziness. Now, they're all 7s, so that's a 7, oops, and this has got to be 7, because that one can't be by Sudoku. And now I've placed the 7 7s on the line. 7 can only touch 1 or 2 on a German whisper line. So bam, in go 1s and 2s, and some of them are going to get disambiguated straight away, because we do have a couple of 1s and 2s in the puzzle. 2, 3, 1... oh, we got 3 on this line, so there are 3 of the same digit, and that therefore means 3 is what happens each time. I thought these were always all going to be absolutely easy to disambiguate, and it hasn't quite turned out that way. That's become a 9. That's just whisper technology. That's a 1-2 pair now. So these two are a 3-5 pair, and we know the order because of 3. That's not a 7. We've got 5, 8, 9 triple in this row. That makes that a 7, which is also on a line and is surrounded by 1 and 2. This is now 3 or 4, and I haven't considered the ends of this line. Right, if these two weren't the same, they would be at least 2 and 3, saying that there were 3 2s and 2 3s on the line. Which cells are available to be 2s and 3s? One of the other ones in column 1, and those 2. Oh, maybe you could just achieve 2s and 3s. That's the only one. You couldn't achieve 2s and 4s, or 3s and 4s, because there aren't enough cells available. But you could either have 2 and 3 in the ends of this line, or 3 and 3. 4 here is nonsensical, because you can't have 4 repeated low digits. So that's a 3. Is that literally all I got out of that? That's amazing. This is 8 or 9 by German Whisper, and it's 8 by Sudoku, therefore. And there's a 3 here. Oh, this is an odd puzzle, I thought. So I'm going to debunk 2 and 3, I hope, because then we would have an extra 3 to go on the line there, and no, that would be a 2. If it was 2 and 3 on the ends of this line, that would be 3, that would be 2. I mean, I think that does actually work. And 3 3s on the line puts 3 here and here, and I think that works. What a peculiar line. It's keeping its secrets till the very end. Okay, 7 in this row has got 1 and 2 beside it. And oh look, this is a I-wing, the last digit needed to complete the column. Then we've got 4, 5 and 8 in these cells. Only one of those is high, so the markings come into their own. 4, 5, 3. We've got 6 and 9 to place in books. 7 in the corner cells opposite each other. This, by German whisper rules, has to be a 9 now, and that does too, because neither of them can be 8s. That fixes the 6-9 pair there. 9 fixes the 8-5-9 triple. Oh, this is actually going to spring loose. That fixes the 4-5 triple. This one is where 4 goes in the column. That's a naked 6, given what it sees in the row and the box. That's a 1 or 2. And this is where 6 goes in the box. Now, this is a 4-8-5 triple. Still don't know about the 1, 2, 3 on this left-hand line. But this is a 4-6 pair. In fact, it's not a pair, I can write them in. Cool. Okay, the whisper thing, no, none of the whisper numbers are going to resolve anything for me. Going to have to do it on my own. That is a naked 5. It sees everything else in its row and column. I think that's going to be helpful. That fixes a few things up here. This is an 8, only thing it can be in the row. Now, we're getting close. 4, 5 and 6 in this column. That is a naked 6 to start with. That's a 4-5 pair. In fact, we can do the bottom cell because there's a 4 sitting in that corner. That's 1 or 2. This is a 6. That's an 8. This is a 5. And this digit, in its column, it needs to be a 3. Now, I think ruling 3 out of that cell finally told us about this left-hand line. That it can't be a 3 here because there's no third 3 then you could put on the line. Isn't that intriguing that we had to go that far? So this is a 2. I mean, Sudoku will probably do it from there, but let's use the line to make sure we've done it right. We need 3 2s and 2 3s. We've got the 2 3s. We're going to get a second 2 there, and that must be a 2. And there, we've used the lines to their full extent. That's now 2. This is Sudoku now. 1, 2, 1, 2, 1, 2, 1, 2, 1. And that's it. What a fantastic puzzle. Oh, only 4 people have solved that. I hope it's more now by the time you see it. That is absolutely epic. I love that puzzle. That's so clever. So interesting. How many of the lines had repeat digits on each end? Obviously the 7 line did. This was a 4 line, and this was a 3 line. So this line didn't because it couldn't, but this line was the cheeky one that kept its secrets till quite late on. Great fun. Thank you, Lithium Ion. Thank you, Holes and Atom. Very well done. I like that a lot, and I hope you had good fun with it too. We'll be back with more Sudoku tomorrow. Thank you for watching, and hope to see you again soon. Bye for now.